and this is Career Navigation with LinkedIn Job Posting Insights, my class project for CSPB 4502 Data Mining. Questions. This project had the goal of helping others navigate their chosen career path by uncovering valuable insights from the LinkedIn job market. By discovering industry hotspots, trending skills, and popular skill sets by industry, I plan to help others plan for success. Based on your industry, I plan to answer the following questions. In what regions and cities are jobs booming? What are the best skill sets to have? Which skills are in high demand? Step 1. Data preparation. The first thing that I sought to do was remove rows with null values and postings without corresponding skills list. I then dropped columns that were irrelevant in the scope of this project and split and transformed skills lists from a string into comma-separated values and joined it to job postings for better analysis. Here are lists of tools that I used. In terms of data, I use Job Skills CSV, which is a list of skills which correlated by a foreign key, which was the URL, to postings held in LinkedIn Job Postings CSV. In terms of the geospatial analysis, I use uscities.csv, which contains the latitude and longitude lines that I use to geocode US cities for each job posting. I then projected these latitude and longitude lines onto the state's shapefile. In terms of tools, the language that I used for this analysis was Python in the format of a Jupyter notebook. I used the libraries numpy, pandas, math, counter, matplot library, seaborn, scipy, natural learning toolkit, and mlextend for a priori. Industry classification. Firstly, I designed a function to tokenize the job title and company name for comparison to any keyword map. I then systematically and manually refined an industry keyword map for industry classification that ended up to being 192 keywords and classifying over 1 million postings successfully. I then validated this classification by comparing postings skills to the most popular skills in the industry to gauge industry fit. I then removed over 300,000 invalid classifications for being a poor industry fit. Here are some of the insights gained from this classification. We learned a lot of information about which industries make up the majority of the job market, including administration, healthcare, financial services, engineering, consumer goods and services, and technology. Top skills in some of these industries include sales, accounting, data analysis, patient care, nursing, registered nurse, data analysis, SQL, and Python, each distinct skills for their industries. I then continued this data analysis with a geospatial distribution by industry. I first cut down the data frame to a specific industry, then loaded in the US cities data frame and geocoded each posting. I then compared and removed non-US postings and dropped postings where coordinates could not be found. I then loaded in the US shapefiles and joined posting counts to the map on state code. I then represented postings on the map as dots, labeled the top cities for each posting in that industry, and then conducted geospatial analysis on both the national and state levels. Here are geospatial insights on the national level for the healthcare industry, where it is clear that California is a clear leader among states for the number of healthcare industry postings, with some of the top cities including Los Angeles, Atlanta, Chicago, and Boston. In addition, on the national level, here is the technology industry, where California is a clear winner amongst the states once again, in top cities including San Francisco, Seattle, Chicago, and Atlanta. On the state level, you can see the healthcare industry plotted in Colorado and the technology industry plotted in California. Once again, we see similar distributions with top cities for the healthcare industry in Colorado, including Denver, Aurora, Colorado Springs, Pueblo, and Grand Junction. In terms of the technology industry in California, we have San Francisco, San Jose, Los Angeles, Irvine, and San Diego. Let's move on to frequent skill sets with a priori algorithm. The first step was to cut down the data frame to a specific industry, then collected a sample of zero point 0.1 from this industry specific data. The data was then encoded using transaction encoder from ML and a priori was applied, also from ML. Here are the results on applying the a priori algorithm to the technology industry. It is clear that in terms of three set item sets, Java, Python, and SQL has the highest support. Some of the knowledge gained from these insights was the proportion of the job market given over to each industry, the most valuable skills prevalent in each industry, regions with more frequent job postings in each industry, states and cities with the highest proportion of postings within each industry, and frequent skill sets within each industry. The insight application. By understanding the industry as a job proportion of job market,